homework that I'm assigning is your in-class, is going to be thought of as an in-class assignment that you turn in. So all the homework that I'm assigning.
Yeah.
So I think I already assigned one, right? Yeah. We can either have it turned in on Monday, or you could submit electronically. Either way is okay.
Because I did them in my calculus class and didn't know what I was doing. Then I did them again in calculus and was like, oh, now I get it.
But here's why I wanted you to be able to work together, because if I'm not around and I wasn't here in class Wednesday and you had a video, that's true, it's me on the video, but you can't interact with me. You can't ask me things. You can only watch the video, but if you have each other, you can ask each other questions. So that's why I wanted to open it up and say that, you know, you can turn it in as an in-class assignment working together. And I think that's a fair compromise. I'm still available. You can still call me. I'm in a very pure math department over the weekend, so it's the right environment. But it's not quite the same as being on site. It's really, I'm probably the most keen to do a hybrid course, and I have reservations like that. You know, like what if they can't ask me something? Okay, so hopefully you found all the subgroups of D3. You had I like the approaches listening around the class. Like Ryan had a nice approach of looking at what would be closed under the operation by looking at little pieces of the Cayley table. That's one way to do it. Another way to do it is to look at possible generators, which there's no guarantee that all the subgroups are cyclic, but it turns out in this case all the proper subgroups are cyclic. So you can catch them all by doing that. You just have to examine the Cayley table and make sure you cut them all. You should have had a total of 6 subgroups. Trivial, the whole thing, and 4 subgroups generated by all the 3 reflections and 1 rotation. Correct? Okay. So what are the orders? How are the orders? What were the orders of these subgroups? 2 and 3. And 2 and 3 both divide the order of the entire group, which was 6. So that's the relationship. And for each divisor of 6, did you find a subgroup of that order? That's true. And you found them, so you can list it. So you could, there's the table again, but you could have used that representation from your presentation.
Is that always true?
Huh?
Can you always find, if it's divisor, can you always find that?
Well, we're going to get to that. It's punchline. So the idea of cosets, I'm sure everybody had an undergrad abstract class. The idea of cosets, you're really doing the same thing that we did with integers and modding by n. If you recall that I talked about integers a while back, and that we really, when we're modding by n, we really think of it now as the remainders maybe. But really what you're doing is you're taking the entire group and you're putting them into packages. And for example, Z2 would be 2 boxes, one labeled 0, one labeled 1. Anything that was even went into the box labeled 0, and anything that was odd went into the box labeled 1. And there's no intersection between the 2 boxes. And now you can do stuff with the boxes. I can take the box and add it to itself. So I have an addition. You can even do multiplication. So it's really nice stuff. So you can do the same thing here with subgroups. You can take your whole group and then break it up into pieces based off of, like, in fact, in Z and Z2, you're taking the number 2 and using it as a reference to chop up your original Z, correct? And when you take Z3, you're using the reference number 3 to chop up Z into 3 boxes. So in the same way, we can take a big group like Z8 and take a reference, take H equals the cyclic subgroup of 4, and then chop up Z8 into pieces using that reference H. It's the same idea. And this is what I think Fraley does actually beautifully. He explains this beautifully. And I actually wanted to show you, just to remind you, H is not all of Z8. It's the subgroup 0, 4. And I was at 112 slides, and I thought, okay, I don't want to put his picture on there. I'll actually have you look at that picture, but do look at that picture because it's the best thing out of the book. So you're putting things into a box, and the box is really A inverse B belongs to H. So I did a few calculations here to show you what I mean. So you can take just like you do with the even number 2. And then look at, so how is 1 related to 2? Does it go in the 0 box? No, it doesn't. It goes in the other box, right? So you can look at number by number on the integers and ask yourself whether it goes into the 0 box. In the same way, I can do this little experiment and chop up the entire Z8 into boxes by asking the question, does it go into this criteria, a relationship? And I think Fraley actually has you break it up initially into this way, looking at this relationship. So for example, if I look at A equals 0 and take B equals 1, does B equals 1 belong to 0 plus 1 belong to H? The answer is no. Does 2 belong to H? The answer is no. The first element that belongs to H is 0 plus 4 belongs to H. So it's the same idea as taking the integers and asking which of those integers went to the 0 box. So the same kind of question. So box 0 is really H. I could do the same thing for box 1. I can take the A to be 1 and then look at what elements in that Z8 went to the box labeled 1. So I kind of got tired of this after a while, but you get the idea. I'm just grouping up all the elements and putting them in their correct boxes. And so on. So this is about the time I got tired. You're looking at me and saying, that's all it took to get you tired? We got Paul who plays hockey. That should make you tired, right? And so I listed all the boxes. You can figure out the boxes and figure out the pattern. And notice that some of the boxes repeat. I had a box over here that's the same box over here. So there may be a doubling up of boxes, just like the integers mod 2, right? Some of those elements went in and they were in the same box. But we don't say box. We say coset. And those things were called left cosets. So I'm going to give you the formal definition, and this is in Fraley. Let H be a subgroup of G, and the subset AH is equal to AH, little ah, such that H belongs to H. And that's called the left coset of H containing A. Ha is the right coset, so you can also have right cosets. So this is what I mean by dry stuff. This dry stuff is right out of Fraley. You can pull it out. So use the definition. I'm going to go back to the definition. So write down the problem, and then I'll go back to the definition and just calculate, like I did, putting things into boxes, what the left coset and right cosets with H equals 4 and the A equals 2. So just do the calculation for left and right cosets and see what happens. So I'll go back to the definition after you write down the problem. So you can just look at the definition on the screen. This should be a quick computation, actually. Yeah, it's with addition. Or do you want me to go back, David?
Yes, I just want to write this down.
Okay.
And then Jeff is telling me his thinking and the answer, and I'll write that down. It's just too much at once.
I just know, like,
The lesson right there.
it's feeling.
Because the addition of
Yep.
I did it her way, but I happened to only fix it.
I do, yes. So I'm always on my test.
It's weird abstract. How did she even write all those matrices out yet? Or videos?
Yeah.
I look up
My favorite though is that he called me Speed Demon. No, he did. Song did. Or Speed Racer. Speed Racer. No. Song though. I was so scared of those first class. I loved it.
Yeah, I guess so. Most of the,
I
I kind of stumbled into the teacher that taught calculus.
I would have liked to see that.
And I don't see how it's retired. And nobody else can
Yeah,
work
after I
with it,
took
so I don't know how I
complex
stumbled into
and
it.
linear, I would think they still need really quick.
Yeah, oh, it is.
It's like I've known
now, and I feel like my whole
yeah, like
reshaping what I think I college.
But yeah, so I had focused in on songwriting
Yeah.
letters and different
I used to read a whole
yeah.
I used to read a whole
I'm
thing
adjusting
on
that.
why they use
It's my first time.
I have Jen Fano over there. She says, "What come out here and talk to here so about what to expect." Because I asked her, do they know before they come in about professional development? All
Oh,
this
I'm
stuff?
understanding all the
Like, isn't it kind of a shock to the system of
Well, we just
the evaluation of that other weird
B
thing?
is in HA if and only
Yeah, I
if
mean,
A inverse B.
you kind of learn to do two. You do all the way down to
I think
2
that's
plus
what's
5.
It's a lot.
You did 2 plus 6.
It's overwhelming and it's
Yeah, so we're deep into
Yeah, okay.
SGOs and coordinates and SGOs.
Right, yeah. I would have liked to see the theory, like why are we doing this?
You know what I ask, I keep asking this question. Is the only
Oh
evaluation
wait,
of
this should be A inverse, right?
and this is what
That should be six.
supervisor.
Yeah, I said I've never been
Right,
evaluated.
because A
I think that's
inverse
another
B should be
question
in
about
HA.
you. Don't say anything because they're the observers of the class. And the fact that they said it's 20 minutes in the classroom, it's only 20 minutes.
No, that's not right.
Because even when I do peer evaluations, I sit for the whole class.
Well, there's one time they sit for the full class, and then 2 other times they sit for
Okay, that's good.
So 6 is 12.
Oh, right, okay, I'm sorry. I thought it was
But that's that by our school, that's what we
There's
have.
documented evidence showing that people judge classes of the way they do.
My supervisor's not even in math section.
And then we also.
So my supervisor would come in and watch, I could spin anything I want, I could just talk about random nonsense in calculus, and he had no clue.
Like maybe somebody, I remember one time I was observed by somebody who loved to
Yeah, because once you have
and they didn't like it, I didn't have
everything in here can also be used to define.
So I used to best observers are students. Are you learning, what are you, what's helping you learn the most? It's not helping you learn the most. Ask those 10 questions.
I was saying that when A is 2, we develop this coset, which means that H plus 2 and H plus 6
You'd
are
have to create a
so
survey
they can
that.
add any element in the
I
coset
asked
to
Jen if someone
someone.
would ask me, small groups, analysis, break them up into small
I don't know
groups.
what
Have someone come in, independent, not, you're spending 20 minutes writing. Instead, 20 minutes, you go in and ask questions from these questions. What helped you learn the most?
Interview on the
For
basis.
education
And then someone
purposes.
says, you know, they never were in their office, and somebody has to say, oh, their office is not
I actually went through, I went through and every single one of my undergraduates, so like
the REJ and the, you know, like, you didn't mean to allow it, and what is the different various reasons?
there's so many things to learn here. If A is in some coset, it's coset.
That's it, it's interesting, because all these things I proposed work in color.
And, okay, fine,
Yeah.
so A is in
And
H,
there's
A
parents.
equals H1.
There's another wrinkle, you don't
Makes it more
have
complicated.
Then we're gonna let R equals say
Okay, so this one should have been a short computation, right? AH is equal to HA because
it's billion.
it's abelian, so it's a quick computation.